Assalamu alaikum, my dear cadets. I welcome you all. It's a very critical moment to you where the COVID 19 has scattered everywhere in our country and also all over the world. So be safe and sound and stay your home. Don't go anywhere. However excellent you are, I am Mohammad Ashikur Rahman, lecturer in chemistry at Borishal Cadet College. Today, I am going to start my lesson on the chapter organic chemistry, which is included to your chemistry second paper, chapter number 2. The topic which you will be taught today is the concept of some special explanation of some organic compounds. By the end of this lesson, cadets, you will be able to explain the acidity order of fatty acids, explain the basicity of amine, and explain the acidity of phenol and alcohol successively. First of all, I would like to discuss the acidity order of fatty acids. That means the acidic properties of some fatty acids compounds. Okay, now following the structures, chemical structures, this is the structure of formic acid. The UPAC name of this acid is methanoic acid. Now you have to learn formic acid. The it is acidic properties. It can be, it may be show the acidic properties or not. First of all, just follow the structure here. You see a carbon double bond oxygen, that means CO bond is present here, and here the electronegativity of oxygen atom is more greater than the carbon atom. That's why the pi electron in this double bond shifts towards the oxygen atom due to the highest electronegative element of oxygen. So we can get the following structure. Here oxygen accepts the negative charge and the central carbon gains as a positive charge. Due to positive charge, this chemical species will be unstable to the previous structure, that means formic acid, and the stability is due to the positive charge on the central carbon atom. So to gain more stability of this chemical species, the free electron on the oxygen atom shifts towards the central positive charge for neutralization. Then we get the following chemical structure. Here an extra bond is created between a carbon oxygen bond, and we have the following structure. And here you see the oxygen atom, which is connected to the two element carbon and hydrogen, accepts the positive charge because this oxygen element donates or shared covalently coordinate by its coordination bond to the central carbon atom. In this case, the oxygen bears the positive charge. And to neutralize this positive charge on the oxygen atom, the, the bonding electron of OH bond shifts towards the positive charge on the center on the oxygen atom. So ultimately we can get the following structure. Here the OH bond has been broken in this case, and a proton ion is released in this case. And we know that any chemical compound or chemical species which donates proton ion show the acidic properties. So here we can see formic acid donates or release or provides the proton ion or H plus ion by its resonance process. So we can say that formic acid shows the acidic properties. Now I would like to share another example. Here you see the chemical structure of acetic acid. Here you see in similar way the pi electron in double bond shifts towards the oxygen atom due to the more or highest electronegativity of oxygen than that of carbon. So we can get the following structure. Here the carbon gains the positive charge and the oxygen atom accepts the negative charge. Dear cadets, just follow in this structure contains an alkyl group which is methyl group. The methyl group is present here, that's why, and we know that each alkyl group acts as an electron releasing group. That's why this methyl group donates or release the electron density to the central positive carbon atom. That's why the lone pair electron present in the oxygen element cannot move towards the central carbon atom. Ultimately, the OH bond has not broken in this case. So we can get the following structure. Here, the OH bond remain constant in the previous stage. So here, as the OH bond remain constant, that's why proton ion cannot be released in this case of acetic acid. So if we compare two acid between acetic acid and formic acid, that which one is more acidic, then obviously the right answer will be the here the answer will be formic acid. It is not acetic acid. Here the formic acid will be the more acidic acid, because in case of formic acid, proton can be is released more easily than that of acetic acid structure. Okay, now the next example. Here you see the structure of monochloroacetic acid. Here chlorine is here one hydrogen atom in methyl group is replaced by a chlorine atom, and here similarly the pi electron moves towards the oxygen atom due to the higher electronegativity difference between carbon and oxygen. So we can get the following structure. Here carbon accepts the positive charge and oxygen the negative charge. But here a chlorine group or halo group is present in this structure, and we are already known that all halo element, that means all chlorine, bromine, fluorine, etc., these elements acts as an electron withdrawing group. That's why when chlorine is present in this structure, then the chlorine atom attracts the shared electron towards itself. That's why the central positive charge will be more and more positive than that of the previous structure like formic acid and simple acetic acid. As the carbon accepts the more positive charge in this case, so the lone pair electron on the oxygen atom is will be shifted more and more, and we will get the following structure. Here oxygen accepts more and more positive charge. That's why the shared electron between OH bond obviously moves faster to the central to the oxygen positive oxygen atom, and we'll get the following structures, and we can get proton ion by its resonance structure. So we can say that monochloroacetic acid have the acidic properties more and more than that of acetic acid and formic acid. Now, if we consider the next one, that is dichloroacetic acid, obviously the chlorine atoms present in dichloroacetic acid attracts the attracts more and more the shared electron, shared electron in bond. So the lone pair electrons present in oxygen atom shifts more and more to the central carbon atom, and the OH bond has been very weak in this case, and proton is released more easily than that of the previous structures like monochloro, acetic acid, formic acid, and acetic acid. So we can say that dichloroacetic acid is more stronger acid than that of the previous one. Now we will show the next one. Here is the structure of trichloroacetic acid. Here obviously this acid is more stronger, will be more stronger than that of the other another acid, another fatty acids, which is shown in this lecture, because here the chlorine atoms, all chlorine atoms attracts the all bond electrons more and more, and obviously the free electrons of oxygen atom moves more and more. So the OH bond is will be very weak in this case. So trichloroacetic acid is more stronger than any other fatty acids shown in this lecture. So now just think about it, which one is more acidic between among monochloroacetic acid, dichloroacetic acid and trichloroacetic acid. Obviously the correct answer will be the trichloroacetic acid. Okay boys, now some findings of this lesson. Here we can conclude here some of the findings. The first one is trichloroacetic acid is more stronger than dichloroacetic acid, and dichloroacetic acid is more stronger than monochloroacetic acid, and monochloroacetic acid is more stronger than acetic acid, and acetic acid is less stronger than formic acid. Okay, now the home task for you. Here is a creative question for you, and by using this stem, you may be solve the following questions. First of all, you can be able to solve the definition of fatty acid, and then the next one is why acetic acid is acid. Just prove it, and then the next one is an explanation type question, which is the compound A is more acidic than the compound B, and finally you can be able to solve the analyzing question, why the chloro substituted compound of B compound have the more acidic property than that of compound B. Okay boys, and the next topics, that is that means the acidic properties of basic amine and phenol and also alcohol will be discussed in the next lecture. Okay boys, be safe and sound and stay your home. Don't go anywhere during COVID-19 pandemic. Okay boys, thank you and thank you all.